An automatic door in an office complex is operated by a motor, M, which is controlled by 3 inputs. The Boolean expression for the system is M equals A, the dot means and B, or C. So it's A and B or C, where A is a darkness sensor, B is a pressure pad, C is an inside switch, and M is the motor. Complete the truth table for the system. Okay, so it needs to be A is a 1 in the dark, B is a 1 when it's pressed, and C is a 1 when it's pressed. So it's A and B or C. So the bit they've given you, see that one's got a C, so it's got a 1 for the M. So it's a C, a 1 there, a C, a 1 there. This one hasn't got a C, but it has got an A and a B. So that's a 1 there as well. That one doesn't have an A and a B, but it does have a C. So that's a 1. Doesn't have A and B, doesn't have C, so that's a 0. State with reference to the data booklet, the full name of the ICs required to build the circuit. Right? So we need an AND gate, which is a 7408, and we need an OR gate for that one there, 7432. Right? The full name of the AND gate is a quad 2-input AND gate. The full name of the OR gate is a quad 2-input OR gate. Right? State the name of the family to which these ICs belong. Right? If it starts 74, that means it's a TTL chip. The supply voltage TTLs need is plus 5 volts. Okay, the CMOS ones need between 3 and 15, but the TTL need 5 volts. The 5 volts is quite a difficult voltage to achieve. Okay, complete the wiring diagram for the door control system. Right, the first thing to do is put on 1, 2, 3, 4 power lines. Okay, now it's A and B, so we'll take the B up to that input there. That's the output. So take that output and get in there, and it'll be R3, and that'll be it. If you're stuck doing a question like this, look at your data booklet and draw on the gates in these blank spaces here. The purpose of the dot is to tell you where pin 1 is. The notch there does the same, tells you which way around it is. That's pin 1, 2, 3, 4. It goes around anti-clockwise. When a pupil was modelling the circuit on a breadboard, an LED was used to show a high output. State the full name for an LED, a light emitting diode. Okay, the symbol, it's a triangle with a line on the end of it, and then 2 arrows coming away from it. A disco light box is controlled by a microcontroller. Different coloured lights are reflected by a rotating mirror. The mirror's position is sensed by a rotary potentiometer. Okay, there's rotary potentiometer. Part of the P-basic control program and details of input and output connections are shown below. Right. Now, this isn't the question. This is just showing you that the motor with pin 7 high goes clockwise, with pin 6 high goes anti-clockwise. The red light's on 5 and the yellow light's on 4. And the sensor A is on pin 0. Okay. Now we've got 2 bits of code. So if sensor A is greater than 150, then ACW. Okay, so it's a question. So it's saying if A is bigger than 150, then you do ACW. Okay, but if it's less than 150, it comes down and it does this bit of code here. Okay, it does itself. Okay, so the code here is saying motor clockwise, red on, 10 millisecond delay. Again, motor clockwise, but now the red's off, so it's making the red flash as it goes around. Another 10 millisecond delay, and it's jumping to label clockwise. Okay. So it jumps around to itself until sensor A is greater than 150. Then it comes and does the anti-clockwise one, which makes the yellow one go on and off, okay, whilst rotating anti-clockwise. So here's the flow chart. If sensor A is bigger than sensor A bigger than 150? Well, if it's not, it does this, and if it is bigger than 150, it does that. So let's just flip back to the other question. So is sensor A bigger than 150? Then anti-clockwise. Okay, so we need to put the yellow on, and the motor needs to go anti-clockwise. So it's bigger than 150, hang on, it's bigger than 150 and less than 30. So when you go, is it sensory bigger than 150? Yes. Is it less than 30? If the answer is no, then it comes down here and does the anti-clockwise procedure. If it's yes, it loops back up to that one. Okay, so this will be the clockwise one, and this is the anti-clockwise one. So motor clockwise, red on, motor clockwise, red on, 10 millisecond delay, 10 millisecond delay, red off, and another 10 millisecond delay. That's a 10 millisecond delay, that's a 10 millisecond delay, and this one is the motor anti-clockwise and yellow on. Name the microcontroller parts A to E shown in the diagram below. Right. E is the clock. Right. The clock is the thing that drives the microcontroller forward. C goes in the middle of any diagram like this. C is the arithmetic and logic unit, or the ALU. A is the ROM, and it is memory that feeds into the ALU, and B is RAM, like the B0 and B1, B2. They are all parts of RAM. So the RAM can go into the ALU, or it can come from the ALU into the RAM. The D is the input-output port, which matches you up with the real world. Electricity can be generated from both finite and renewable resources. The government is promoting use of renewable sources such as tidal, solar and wind. Explain one disadvantage which must be considered when using each of these sources. Each disadvantage may be used only once. Okay. Disadvantage of tidal, you need quite it's a big expensive installation. Solar power, you're relying on the sun, and the sun won't always be shining. Wind, it's not always windy, there might be bird strikes. Okay. State two other examples of renewable energy sources: geothermal and biomass. State two examples of finite energy sources. The finite ones are things that will run out. We're talking about coal, peat and oil.